So Akshantha is a student at the Kennedy Middle School, and she is going to be speaking about ensemble machine learning and deep learning for thyroid disease detection. So I'm going to stop sharing. Akshantha, I'm going to make you the host so that you can go ahead and share the slides and your video. Whenever you're ready, go ahead.
All right. Hello, everybody. My name is Akshantha Kumar, and I'm an incoming 7th grader. And my project is the diagnosis of thyroid ultrasound images using an ensemble of deep learning methods. So about my project aims to develop an effective technique that can accurately diagnose if a thyroid ultrasound image is malign or benign. And it does this by evaluating a series of 3 CNN models and 3 ensembles. So the 3 CNN models are ResNet 152, ResNet 101, and MobileNet v2. The motivation for this problem was that thyroid cancer is a serious problem. It is one of the most common cancers in the USA, and in this year, it's expected that there will be 43,800 new cases and 2,230 deaths. And in detecting thyroid cancer at an earlier stage can improve patient outcomes, as you can see in this image to the right. My solution was that I imported 3 models from TensorFlow, which is an end-to-end platform for machine learning tasks. And then I combined these models to create 3 ensembles. I used Google Colab to write my code and run my experiments. And my experiments were hyperparameter tuning with the individual models. I got my data from the TDID database, and it initially had 63 malign and 14 benign images. And since this dataset was relatively small, I used augmenting techniques such as flipping and mirroring the images to get 189 malign and 42 benign images. So a little bit about augmenting techniques is that it's really useful because for small datasets, it can increase the number of images. And what it does is that it technically just alters the existing data. Like it can rotate, it can flip, it can mirror. So those are just a few examples of what it can do. My AI. So I used MobileNet v2 and ResNet algorithms. And I used the 3 CNN models to create 3 ensemble models. And my 3 ensemble models were the voting ensemble, which took the majority vote from the 3 CNN models, a confidence score ensemble, which took the average confidence score from each of the 3 CNN models, and then the reduced false negative ensemble, which used strict criteria to reduce false negatives. My experiments and results. So taking a look at the right side first, you can see that there's 3 graphs for each of the individual models. And these are ROC curves, so which show the true positive rate or how well the model can predict true positives without predicting false positives. If you look at the one in the middle, the ResNet 152, you can see that it has like a perfect 90-degree angle, which means that it can predict true positives without predicting any false positives. Now looking at the AUCs, which means area under the curves, taking a look at ResNet 152, we see that it has an AUC of 1 because it can predict true positives without predicting any false positives. And then looking below it, we can see that the ROC curves for ResNet 101 is really close to being a 90-degree angle, which is really close to being perfect. So the AUC is just 0.98. And then at the very top, the ResNet 152, it does, it has a ROC, it has an AUC of 0.95, which is the least of all of them, because it just doesn't predict a malign without predicting malign, like when the really image is benign. So now looking at the left, my experiment was that I tested all 6 models, which include 3 ensembles and the 3 individual models on a test data set. And all the accuracies were really similar, except that the reduced false negative ensemble did slightly better. What I learned in this project was that false negatives are really important to reduce, especially in the health field, because if a patient does have thyroid cancer, but the AI predicts it as negative or predicts the thyroid ultrasound image is benign, then the patient will just walk away without knowing that they do actually have thyroid cancer. And then their patient outcomes won't be as great as if they had detected it in an earlier stage. I also learned that ensembles are a really useful technique and can be used to improve the accuracy for much more AI projects. In the future, I want to create a simple website so that AI can be easily accessed to doctors. And I also want to get more data because my data set is still small. Thank you for listening, and put any of your questions in the Q&A.
Thank you very much, Akshantha. So there are a number of questions that you can make me the host again. So the first question is regarding the skew in the samples, because the number of, malign and benign wasn't about the same. Did you find that that was a problem?
Yeah, it was really biased, and I did find that it was a problem until later in my project, so I couldn't do much about it. But if I were to continue this, I would definitely add more images into the benign category.
Makes sense. And did you find that, it looked also that the accuracy was quite high also for your regular AIs as well. So did you find how much the ensemble helped you?
Oh, for my hypothesis, I just wanted to create an AI that can accurately diagnose it. And then I think using the false negative ensemble, since it's really vital to reduce false negatives in the health field, I think the false negatives really helped.
Okay, wonderful. Well, thank you very much. Great presentation. Thank you, Akshantha.